All right, hi everybody. Real quick, we're just going to finish up the spreadsheet from today. So I'm working through this a little bit before class starts. So you can have this in case we don't finish it today. There's going to be some videos on your assignment today that you can watch, and this might be one of them. So just a recap of yesterday. Let's put this over here. We talked about, we have our data on our colleges that we're applying to. The mean number of colleges is 5.2. There is a video in your assignment that I encourage you to watch about what the mean actually is, the meaning of the mean, I guess I would say, the interpretation of the mean. So what we would say here is that 5.2 colleges, I think this is important, per student is the mean, and it means, or the average, and it means that 5.2 colleges per person or per student is the balance point of the distribution of total colleges that students in Mr. Bokar's third period AP Statistics stats class are applying to. So it's the balance point of that distribution. So if you, we're going to look at that with Staplet, but that is literally like the center of mass. Like it will, if you had to put them all on dot plot, like we'll see on Staplet in a second. If you had to put them all on a dot plot, you would put your finger on 5.2 and it would keep the dot plot balanced. It wouldn't tip one way or the other, just like a seesaw. Okay, so that's literally the balance point. It's the number 5.2. The mean is the number that keeps the distance to all the values to the left and to the right of the mean equal. Okay, so it's literally the balance point of the distribution. That's how we interpret that. Okay, so now to compute our standard deviation, the first thing we do is we need to know the mean, and we find the distance from each data point to the mean. So the distance from 9 to 5.2 is 3.8, and we do that by 9 minus 5.2. And then we did it for 4 minus 5.2 is negative 1.2. So that just means 4 is 1.2 colleges per student below the average, right? So that is what we're doing for each of our data points we have. From there, what we need to think about is, I want you to think standard deviation is going to be kind of like the average distance or the expected distance away from the mean that a typical student in our class is. So I want you to think about it like that. Well, if you do an average, what's the next thing you would do? You find like the average, so you have the distances. Next thing you do is add, and then you would divide, right? Well, the problem is some of these are positive and negative. So some are going to cancel each other out, right? They're going to make 0, and we don't want that, because that's if we get something close to 0, that's telling us that there's no variation in our data, which is not true. So in order to take care of that, there's two things we really could do here. We could make all of these the absolute value. So we would take like just the absolute value of the distance, and that would give us literally the distance, just the raw number distance away from the mean. And then we can average those. That is a statistic called the mean absolute deviation. It's used. It's another way to measure spread. However, there's a problem with it. If you take any calculus or have taken it or even pre-calc, the distribution or the absolute value function has a corner. It's not great to do like calculus with, so we don't really use it. But instead, one other thing we can do is to make all of these distances positive. We can actually square each of these distances. So we square 3.8. So you do a little caret, you click on it, square it. And what does that do? What that does is it makes all of these distances a positive number, so we can take an average but not worry about canceling out. And it also takes distances that are equally negative and positive. So like a positive 1.2 and a negative 1.2, they're the same distance from the mean, right? Just one's below average and one's above average. And when you square that, when you square both numbers, you get the same thing, right? Like 1.2 squared is 1.44, and so is negative 1.2 squared is 1.44. So those people, so someone at 4 versus someone at like 6.4, there'd be both. One would be 1.2 above the mean, one would be 1.2 below the mean. They both contribute the same number to our variation, right? That's how far away from average they are. So we do that for each data point. We square their distance to the mean. And then and then we take the sum, we total them. So you take the sum, so we're going to total. So we do the sum of this right here. Take the sum. Okay, we totaled. So this is our total squared distance. So that's our total squared distance. We find the average. So once we have a sum, all we need to do is divide the sum by however many data points there are, right? To find the average. So we take this and we divide that by however many data points we have. And we had one, I think we had, let's see, 3 all the way down to, I think we had 15 data points. So we divide by 15. This is our average or mean squared distance. And then so this is all about squared, right? It's all squared. So the units right now are actually in colleges per student squared. Okay. To get them back to a regular unit, we take a square root. So we take the square root of this number. So the way you do that is you type SQRT, square root, and you click on this number, close the parenthesis, and there you go. It's 1.75878, blah, blah, blah. Okay, so a couple things here. I'm going to unfill this. Okay, this number, the average or square distance, is called the variance of the number of colleges, and it's in units squared. It's called the variance of the number of colleges. This is called the standard deviation. This is your standard deviation right here, the number of colleges. Okay, so the square root of that, of the variance, is called the standard deviation. We usually use the Greek letter sigma to represent colleges, or to represent the standard deviation, and the variance is sigma squared, which makes sense because we take the square root to go from here to here and vice versa. This is for a population, and if we're talking about our students in my class, you are a population. You're the student. You're all the students in my class. So this is for a population. Okay. And then we also have a standard deviation that's slightly different, which we're going to look at in a second. But this is the idea. You find the average of the distance. You basically find the average distance. The way we interpret the standard deviation, I'm going to put the interpretation here, is here's your interpretation. On average, students in Mr. Bocar's third period AP Stats class apply to, or class have total colleges applied to that vary about 1.759 colleges from the mean of 5.2 colleges per student. That's what that means. And on average, it varies about that much. So a typical student in my class has about 1.8 colleges above or below 5.2 colleges per student. So this is just another side note with that to add in there. Typical student has colleges somewhere between 5.2 minus 1.759. Which if I do a quick calculation, is 3.1 colleges to 5.2 plus 1.759, which is 6.959 colleges. So typically, students in our class fall somewhere between 3.441 colleges and 6.959 colleges. Okay, so that's the idea of the standard deviation, and this is the formula for it, just to help us understand that. If I take these out here, reset, and reset. Okay, So here's a little formula that is that we will use in like AP stats, and so we understand here. Um, so this is X1. X1 is just the first person in our list. So X1 is just data point 1. X is our variable, and that's the mean, or I'm sorry, the number of colleges you apply to. So X1, the first person had 9. X2 is 4. X3 is 5. So person 5 had 5 colleges, and so on. Then you take the distance to the mean. The mean is typically denoted with X bar. We'll talk a little bit more about that. But that's the notation for the sample mean for our class, or just the average. 9. So we take all of these, subtract xi, just means x1, could be x2, x3. I is just the index, just tells you what person number. So you take each person, subtract the mean, find the distance. Then you square that distance for each person. And then sigma, I have videos in there for you to watch, are all about, this is about summing. That just means sum. Take the total of those square distances. Take this whole column E, like we did, and just find the total. And then finally divide by 15 to take the average square distance. And then take a square root of that. And this right here will look similarly to the formula we'll see for the standard deviation for AP statistics. So I will get that formula sheet. There's a formula sheet that we're going to use. I'll get that out to you probably tomorrow. I'll try to make a note of that for myself. So this is just how you build the formula for standard deviation and understand like intuitively what it's saying. So I have another video that explains what happens with outliers to all of these things. I have a video that explains visually what the standard deviation looks like when you use it on a dot plot. So I'll encourage you to check those out.